Hi, my name's Mr. Humphrey. I've got your mail from Margaret at the Everson Foundation. Just wanted to go through a couple of bits and pieces in regards to your circuit diagram, which we can see in front of us. I can see that it's not a bad diagram at all, really. There's a couple of bits and pieces which I don't think are quite right, but you've got your power here, which I imagine this is the high side of the circuit. This is the low side of the circuit. You've got your LEDs and your switches, and they come on in different rooms. LEDs are drawn correctly. Switches, we'll come back to that. I'm not too sure what these things are. These sort of square, I don't know whether they're a timer. They're here as well, or I don't know whether they could be a diode. If we go to the next image, here you've drawn a diode, which seems to make sense. If that's high and that's low, that you don't want any backflow going this way. But I think I'm right to say that because this is a diode anyway, this is an LED, you're not going to get backflow into the LED, so you don't need that diode. Again, we've got this little number. I'm not too sure what that is, and so I can't really comment on that. What I would say though with your circuit is generally your problem is it's in series, not parallel. What I mean by that is we're starting with the first room in the series, and then we're going to the next room in the series, and then we're going to the third room in the series, and then the fourth room in the series, and then we're going back to the low side of the circuit. That's one problem, and you really want to be drawing it parallel opposed to series, and we can go through that in a second. Your switches are push to make switches, so that when you push them, a bulb comes on, and when you take your finger off the button, it turns off again. So it will only be on when your finger is on the button. So that's called a push to make switch, or a PTM. I would have thought you would just want just a switch, what's called a single pole, single throw switch, and you draw those slightly differently, and I can just show you about that in a second. So let's just go back to that first image. I think it's worth just popping over to a piece of paper. This is a bit awkward for me, so I apologise if I'm not going to get this right first time, and I'm really stretching. So effectively what you've got is a circuit. I know you've drawn your lines multiple times or whatever, but you have a high side, which I'm going to mark with a plus, and then you've got a low side, which I'm going to mark with a minus. And the idea is the electrons go around the circuit from the high side to the low side, and I'm sure you know all about that. Right, what you've done, and I understand why, you've gone into room, let's say it's room 1, room 2, room 3, or room 4. What I would suggest, opposed to that, is go into room 1 and then back down to the low side of the circuit, and then go into room 2 and back round to the to the low side of the circuit. So what you're not getting here is you're not going from room 1 to room 2, you're just going from room 1 to low, and then we're going from room 2 to low, and then we're going from room 3 to low, and then of course from room 4 to low. And so the best way to do that, if I draw that up for you, is of course this is just a track or a piece of wire, and what I'm going to do is draw a switch in there as a terminal, and that's a switch that you can flick on and off. Now if that comes out and that goes to, as you've correctly drawn, an LED, that could go back around to the low side of the circuit. What I haven't done here is put that master switch. I think you've got a master switch in yours, and apologies, I think, can I rub this out? I've got a rubber on this. There we go. So you would have a switch there. And when you press that switch, of course, that little gate would come across and would make the circuit, join the circuit, and allow the electrons to flow through. So that's what we've got. So that would be in your first room. Now, in your next room, yeah, you've guessed it. It's exactly the same thing. Drawn badly because I'm at full stretch, but I think you'll get the idea. Maybe we can pull this down a little bit and make it a bit easier. Got the switch here, we've got the LED there, and we've got the electrons going back round to low. And of course, what you would have going up from here is you'd have another one there, and you'd have another one here. So effectively, excuse me, I'm just gonna move this, so that would be room 1, that would be room 2, that would be room 3, and that would be room 4. And this might go up to room 8 or something, but you can still sort of see, can't you? And that's your LED there, and apologies for the drawing. The diode. So at any time you can flick any one of those switches and any of those LEDs will light up. Now, just going back to what you've done, and I just explained the problem that's on here, that if you've got your electrons coming out of here, the electrons want the easiest way to get back to this area here, because they want to go from high to low in the easiest way. Now, every time you come up against something, even an LED, or if there's a resistor, it's got resistance, it stops the electrons. And so if there's an easier way the electrons can get around that, then they'll take it. Now if we go from here, electrons are coming up here, they get to that LED, now they're going to hit this switch, and if that switch isn't down, the electrons can't go any further. But when that switch is down, they could go through that LED and keep on going. But they're not going to in a month of Sundays, because what they're going to do is they're going to jump over that, as there's very little resistance in that piece of wire. Can you see that? So if I was an electron here, I mean, I would either go up there and around there and down, or up there and around there and down. And when you press your push to makes, you're not going to get any electrons going through any of these, because there's an easier way to go. And you can see you've done that in all of your little circuits in each one of the different rooms. So that is my suggestion, that you wire it up all in parallel. And it may not seem as logical, but it will work. And the reason it will work is because of that word resistance. Because what will happen here is the electrons will be at, well, when you turn this on, when you click that on, the electrons will be ready to go. And as soon as you click that, there'll be a little bit of resistance from that electron, but there'll be a little bit of resistance from that LED, but the electrons will go through it. And if you click another one, because of the resistance here, it will push the electrons through a second LED, and so forth. Okay? I don't know whether just holding that up is going to help you. It's a bit scruffy, isn't it? If there's anything else I can help you with, if I've missed something in one of those symbols that you've drawn, I apologise, and maybe you've got that from physics and I teach DT, so that might be a problem. But I'd be more than happy if you write me a mail, or write Margaret a mail and she can forward it on, to try and help you again. But that's what I would do. That's how I would wire this circuit, this doll's house up. All right, hope that helps.